This is a 1 3/8 inch bar of 360 brass where a 3/4 inch piece is being cut off for a 23 tooth spur gear. A 31/64 drill is making an undersized hole for this 1/2 inch reamer to make a more perfect hole. I'm setting up a 3/16 inch broach to cut a keyway. A broach works by cutting with ever-increasing teeth, so each tooth removes a small amount of metal. A number 25 drill makes the right size hole for this 1024 tap to make threads for an Allen head set screw. This set screw is needed both to lock the gear blank to a mandrel for machining and to lock the finished gear to a shaft. The gear diameter is determined by adding the number of teeth plus 2 and divided by the diametrical pitch. Notice the gear blank is mounted on a mandrel and held between centers on the lathe. This is to machine it to 1 1/4 inches or 1.250. The teeth are cut 0.108 inches deep, determined by dividing 2.157 by the diametrical pitch. A dial indicator is used to set the depth. This is a set of involute gear cutters with an R8 stub arbor, which holds the cutters in the mill. The diametrical pitch is 20 with a 14.5 degree pressure angle. This number 5 cutter is used for cutting gears for 21 to 25 teeth. The cutter is mounted on an R8 stub arbor. At the mill, a first cut is made. This dividing head has a 40:1 ratio, meaning it takes 40 turns to make one complete revolution. A dividing head is set up by dividing the number of teeth into 40. As the graphic shows, each tooth needs one complete turn of 23 holes plus an additional 17 holes. It's a matter of making one complete turn plus 17 holes as regulated by the placement of the sector arms. The sector arms are then advanced for the next cut, and the next cut is made. And now, trying to avoid all distractions so I don't lose my place, let's make a gear.